Think my screen is visible, no?
Yes, sir.
Yeah, so we can see it.
Okay, okay. So today we'll start with FSM. We complete in the last class we completed with this frequency divider circuit, no? So we'll start with this FSM, finite state machine, Mealy machine, and Moore state diagrams. Okay. So FSM, FSM, Mealy and Moore state diagrams. State diagrams. So first, so finite state machine. So what is this finite state machine? So FSM is nothing but what? Finite state machine. Finite state machine. Finite state machine means this is synchronous sequential circuit with finite states. Okay, FSM is nothing but what? Synchronous sequential circuits. Okay, sequential circuit with finite states. Okay, with finite states. Okay, finite states. So that means we already seen the synchronous counters, no? So synchronous counter is also a FSM. Okay, so this is also a FSM without any inputs. Okay, so without any inputs. Okay, without inputs, that synchronous counter we call as a finite state machine. Okay, so in this there are two types are there FSM. So one is Mealy machine. Okay, Mealy machine, and next one is Moore machine. Moore machine. Okay, first we'll see the what is this Mealy machine. So first Mealy machine. Okay, so Mealy machine, if you see the Mealy machine, the output, whatever the output is there, output is function of output is function of present input, present input, and present state. Output is a function of present input and present state. Okay, so how the circuit diagram will look like means, here for Mealy machine. Okay, so Mealy machine, the output depends on the present input as well as present state. Okay, so if you see the circuit diagram, this is next state combinational logic, next state combinational logic. Okay, combinational logic, and this is state register, state register, and you have output combination logic. This is output combinational logic, combinational logic. Okay, and here you have the input. Okay, so here this input is connected to output combination logic. Okay, and here this one will be feedback to the input. Okay, this one will be feedback to the input. Okay, and here for state register you have a clock, you have a clock. Okay, so that means here if you see from here, the output of the state register, you can say that present state. Okay, present state, and this is nothing but input. Okay, so from this I can say that this output of Mealy machine is a function of what, present input as well as present state. Okay, the output is connected, whatever the output is there, output is connected to the output combination logic. So that's why we the output is depends on the present input. Okay, present input, and output of the state register is present state. Okay, or we can call as present state, we can call as past outputs. Okay, present state we call as past output. Okay, so if you see the state diagram, so you have state, this is one state, and this is another state. Okay, state. Okay, so when it is going from one state to other state, this is input by output. Okay, it is represented like this. Okay, so this is the start of the state or reset state, start state or reset state. Okay, so this is about the Mealy machine. The output, it depends only on the output depends on the present input as well as present state. Okay, so this is Mealy state. Okay, and is it fine? Mealy state. Shall I move forward? Any doubt in this?
No, sir. As of now, everything is clear. You can
Yeah.
go further.
Okay. Okay. So what about others? Okay. Okay. So next you see, next is Moore machine. Okay. So Moore machine, Moore FSM. If you see the Moore FSM, so Moore machine, the output, whatever the output is there, output is function of what? Only present state. Okay, output only depend on the present state. Okay, so from here I can draw, this is next state combination logic, next state combination logic. Okay, combination logic, and you have a state register. This is state register. Okay, this is a state register, and this is the output combination logic, output combination logic. Okay, output combination logic, and this is given to next state combination logic is given to state register. State register output is given to output combination logic, and you have input over here, and output here, output will be feedback to the input. There is a feedback network. Okay, output will be feedback to the input. Okay, so there is a clock to the the state register. This is clock. Okay, so here you are getting the present state. Okay, so here from here, that means output, so there is no relationship between input and output for the Moore machine. So the output is a function of what? From here I can say that output is function of only present state. Okay, output is function of present state, and as the output is a function of present state, here this is a state output is defined within the state itself. Output is defined within the state itself. Okay, and this is a state output is defined within the state itself. Here this arrow marker, this is nothing but input. Okay, input, and this is start of state or reset state. We can call as start of state or reset state. Okay, so this is the state diagram representation for Moore machine. Okay, state diagram representation for Moore machine. Okay, so this is about Moore machine. Mealy machine is nothing but output, it depends on the present input as well as present state, whereas Moore machine, the output depends on the present input as well as only present state only. Okay, this is depends on the present state only. Okay, so we'll see the difference between this Moore and Mealy. Okay, Mealy versus Moore. So what is the difference between Mealy versus Moore? Okay, Mealy versus Moore. What is the difference between Mealy versus Moore? Okay, so here Mealy. Okay, Mealy state machine, and here you have Moore state machine, Okay, so what is the difference between this Mealy and Moore? Okay, first we already see, that means output depends on the, so that means output from here, the output first difference is output is a function of what for Mealy? Present input as well as present state. Okay, and Moore output is function of only present state, Okay, that means here in the Mealy, if input changes, output also changes. Why? Because output depends on the input. Okay, here output doesn't change. Why? Because the output is nowhere depending on the input. Okay, so here the number of states required is the same as the number of bits. Okay, number of states, okay, required is same as number of bits, okay, number of bits, okay. And next here one more extra state is required in the Moore machine, okay. One more extra state is required compared to Mealy, okay. One more extra state is required, okay, is required compared to Mealy, okay. Here it will react faster, okay, faster to inputs, okay, okay. It will react slower to inputs, slower to inputs, okay, when it will react means one clock cycle later, okay. One clock cycle later, okay, okay. This is asynchronous output generation, okay. Mealy is nothing but asynchronous output generation, and Moore is synchronous output generation, okay. Synchronous output and state rate generation, okay. This Mealy is asynchronous output generation, and here this is synchronous output and state generation, okay. And it is difficult to design, and easy to design, okay. So this is the difference between Mealy and Moore, okay, Mealy machine and Moore machine, okay. So here you need to see the Mealy and Moore machine, okay. First we'll discuss about Mealy machine and the design, and next we'll come with the Moore machine, okay. So both, if I tell same time means you'll get some confusion, so that's why first I will tell you the, so how we can design like application means we can design this applications of this FSMs are applications, so many applications are there. So basically we'll discuss sequence detector, okay, this is first one, and we'll discuss serial adder, parallel adder we already seen in the combinational circuit, okay. What are the parallel adders we already seen? 4 bits of data parallelly we are giving, no. For one is ripple carry adder, and carry lookup adder, and BCD adder, okay. These are all nothing but parallel adders, okay. Serial adder means wherever the speed is not that much requirement, but so if you take care of this cost and all those things, we need to go for serial adder, okay. So serial adder and sequence detector we will design by using FSM, that too Mealy as well as Moore, okay. First we'll discuss the sequence detector, okay. Okay. So sequence detector, yes. So first sequence detector. So what is the sequence detector? So this accepts the input a string of bits, okay. This will accepts the input, that means a string of bits, okay. First we will discuss the sequence detector FSM Mealy machine we will discuss, okay. So when sequence is detected, okay, it generates the output, okay, when target or when sequence is detected, sequence is detected. Okay. In this there are two types are there. One is non-overlap. Okay. So what is this non-overlap? So non-overlap means if sequence is detected, okay, so that means again it will start from the from starting bit, means initial state, okay, freshly it will start, okay. So that means final bit of the sequence cannot be the first bit of next sequence, okay. Final bit of the sequence cannot be first bit of sequence, okay, first bit of sequence, okay. And this is non-overlap, okay. Overlapping means what? Overlap means here final bit may overlap, okay. So final bit of the sequence, okay, final bit of sequence uh, can be the first bit of next sequence, okay, next sequence. So final bit can be, we can we can include that final bit, okay. Just 5 minutes, 1 second. Yeah. Yes. So here first we will see the what we call Mealy non-overlapping and overlapping, okay, and the design also we'll see. Next we will see the Moore, okay. So Mealy machine I will tell you, okay. 1 second. Yes. Yes. So first Mealy. So take one random sequence, okay. Take one random sequence, okay. Yes. So Mealy sequence detector FSM Mealy, okay. So take one random sequence, okay, Mealy. Let us take the input sequence B, like 0 1 1 0 1 0 double 1 double 0 1, okay. So I want to so what is the sequence detector means? I want to detect this sequence, 3-bit sequence 101 I need to detect, okay. So first is what? First is let us take uh, non-overlap, okay. So what is this non-overlap? First, if the sequence is detected, the output is 1. If sequence is not detected, the output is 0 only, okay. So here 0 is there, sequence is not detected, output is 0. Here 0 1, sequence is not detected, output is 0. 0 0 1, okay. 0 1 1, I didn't got the sequence, so the output is 0 only. Again 1 1 0, the sequence is not detected, output is 0. And here 1 0 1, 1 0 1 means what? Sequence is detected, okay. So Mealy machine, so immediately it will respond, okay. So this is non-overlapping. So 1 0 1 I got, so 1 0 1 I got means the output becomes what? 1, output becomes 1. And next freshly it will start. This is non-overlapping, no. So in non-overlapping we already seen what is this non-overlapping. The output sequence non-overlapping, the final bit of the sequence cannot be the first bit of the sequence, okay, cannot be the first bit of the sequence, okay. So that is nothing but Mealy uh, Mealy non-overlapping, okay. So that will see. So see here, so here it will start from 0. So this is 0 only, and this is what? 0 and 0 1 1. I didn't got the sequence, okay. So is 0 double 1 0 Here I got the sequence, no? So here I got non-overlapping. So 1 0. Okay, I didn't got the sequence. Okay. Mm. 1 0 0 1. Okay, I didn't got the sequence. Okay. So anyway, suppose here take this one. Suppose here 1 is there. Okay. Here 1 is there. So here 1 is there means, so I am checking for the sequence. So that means this is what 0 only. Double one 0. I didn't got the sequence. The output is 0. Again 1 0 1. I got the sequence. I got the sequence. I got the sequence. The output becomes 1. Again it will start from here. So that means so 0 1 1 1 1 means 1 means what? I didn't got the sequence. The output is 0. Okay. So this is nothing but non-overlapping. Okay, non-overlapping sequence. Okay, and if you see the overlapping sequence, let us take the same sequence I am taking, input sequence. So what is the input sequence? 0 double 1 0 1. Okay, 0 1 double 1 0 1 0 1 0 double 1 0 0 1. Okay, this sequence I am taking. Okay, I am checking whether this is in the non-overlap I am getting or not. Okay, non-overlap overlap sequence. Okay, so in overlap sequence what happens, the output will be the means the final bit of the sequence can be the first bit of the next sequence. Okay, so the final bit of the sequence can be the first bit of next sequence. So that means here I am checking for the sequence. Okay, I am checking for which sequence, that is 101. 101 I am checking for this sequence. So this is 0 only, and this is 0 and 0 1. 0 double 1 means what? 0 double 1 means I didn't got the sequence. So here the output is 0 only. Double 1 0, the output is 0 only. 1 0 1, I got the sequence. 1 0 1, the output becomes what? 1. Mealy. Immediately it will respond. Okay, immediately it will respond. Now what happens, this last bit of the sequence becomes the first bit of the sequence. Okay, so I need to start from here. Okay, so that means next 1 means what? 1 means 0 only. Okay, 1 0. Okay, 1 0 means 0 only, and next 1 0 1, I got the sequence, no? 1 0 1, I got the sequence, the output becomes 1. Okay, and last bit of the sequence becomes the first bit of the sequence. So next, so 1 0 means what? 1 0, the output is 0 only. 1 0 1, I got the sequence. So that means output becomes 1. Okay, so last bit of the sequence becomes the first bit of the sequence. 1 1 means anyway 0. Again 1 1 0 means 0. Again if you see here also 0 0 you will get. Okay, so the last bit of the sequence becomes the first bit of the sequence. Okay, so like this this is nothing but overlap sequence, non-overlap and overlap. Okay, so non-overlap I can draw for this one also, same sequence, just you see. So 1 second, here for same sequence I will draw. Okay, see here, same sequence, the last sequence cannot be the first sequence, so that you can see the difference. Okay, so I am taking the same sequence. What is that sequence? See here, 0 double 1 0 1 0 1 0 1 1 0 0 1. Okay, so here 0, I didn't got the sequence. 0 0 1 0, and next 1 0, and here 1 0 1 1 1 0, so I didn't got the sequence. 0 1 0 1, I got the sequence. Okay, this is the sequence. Okay, next it will start freshly. So this is the next state. Okay, the last bit cannot be the first bit, so that means 0 means what? 0 0 1 means 0 only. Again 0 1 0 0 only. See here, 1 0 1, I got the sequence. No, output becomes 1. Okay, again it will start from 1. Okay, 0 1 0 0 1 0 0 0 1 0 0 1 means a 0. Okay, so there is a difference between these two, no? There is a difference between non-overlap and overlapping sequence. Non-overlapping and overlapping sequence. Okay. So this is about the sequence detector. Okay. Today I will explain you the how to draw the sequence state diagram for Mealy non-overlapping, and tomorrow we will see the design part. Okay, how to design this Mealy Mealy FSM for non-overlapping and overlapping. Okay, is it fine? Shall I move forward? Yes or no, or any
Okay, sir.
queries,
Okay, sir.
any doubts?
No, sir. No doubts. You
Okay,
can.
okay. So next, state diagram steps of sequence detector. Okay, state diagram steps. If you see the state diagram steps, state diagram steps. Okay, steps for sequence detector. Sequence detector. So if you see the state diagram steps, these are the steps common for both Mealy and Moore also. Start with initial state. Start with initial state. Initial state. Okay. Add a state that recognize the first bit. Add a state that recognize first bit. First bit. Okay. Add the state that recognize each successive bits. Okay. Add states that recognize each successive bits. Okay, successive bit. Each time when add an arrow determined, it can go to one of the previous state or new state must be added. Okay, so each time when add an arrow, a arrow, okay, so it can go to where it can go to. So that means it can go to one of the previous state. Okay, one of the previous state or new state must be added. New state must be added. Okay, add state transition or which specify when bit is not in proper sequence. Okay, so add state transition. Add state transition arc. Okay, which specify when a bit not in a proper sequence. So that means which specify when a bit is when a bit not in a proper sequence. If sequence is detected, it will go to the next state. If sequence is not detected, you need to add an arc so that it will move to somewhere. Suppose like S0 is there and S1 is there. Okay, if frequency is detected, you need to add an arc. It will go to the next state. Suppose if sequence is not detected, you can add this arc so that it will be in same state or it will come to S0 like that. Okay. So final state represents the sequence is detected, sequence occurrence, and denoted output becomes 1. Okay. Uh, final state represent. Okay. Represents the input sequence, whatever the input sequence you are searching. Okay, input sequence. Okay, input sequence occurrence and denoted by 1. Okay, so these are the steps you need to follow for both FSM, that is finite state machine, for both Mealy and Moore. Okay, so these are the steps. So I will draw the state diagram for what both Mealy and Moore. First non-overlapping I will draw. Okay, and overlapping I will draw. Okay, so 101 sequence. Let us take 101 sequence. 101 sequence. First I will draw with non-overlapping. Okay, non-overlap. So if you see the non-overlapping, first here what I am doing, so S naught, okay. So let us take, so it is a Mealy machine. Mealy machine, what how many bits you are checking, that many states you have. So how many states you have? 3 states you have, okay, 3 states you have, okay. So let us take so 3 states, S naught, S1 and S2, okay. So you have S naught, okay, S naught. Here let us take this is a initial state. So here each and every state you need to check for 0 and 1, okay. And 0 and 1, if sequence is detected, it will go to the next state. If sequence is not detected, next it will go to the initial state, okay. Mealy machine, it will go to the initial state. So suppose if it is a 0, where it will go, it will be in the same state, okay. Let us take this is reset state. I am starting the state, reset state, okay. And if it is, so what is the output? I didn't got the sequence. Output equal to what? 0, okay. Mealy I told you, that means what? State, and it will be like input by output, no, input by output, okay. So here I got the so next I need to check for what? 1. So 1 means what? 1 sequence is there, okay. 1 sequence I got. So 1 sequence means for 101 I got the sequence, it will go to the next step. This is what? S1, and the input is 1. I didn't got the sequence, output is 0, okay. So here at S1 I got what? 1, okay. I got 1, okay. And so at S1 I can get what? 10 or 11, okay. If it is 10, where it will go? If it is 10, I got one sequence, no? I got one sequence. It simply, when you are searching the sequence 101, if sequence is matching, simply it will go to the next state, okay. So here it will go to where? S2. It will go to S2, okay. So that means here input is 0, and I didn't got the sequence. I got a sequence only 10, so the output is 0 only, okay. So here at S2 I got the sequence what? 10, okay, 10. And I need to check for 1 also, okay. So 11 means what? 11 means just I am checking 1. So here 0 is there. When it will go to here, what input is 0 is there, okay. So 1 means what? It will be in the same state. 1, I didn't got the sequence. 1 I got, the output is 0 only, okay. The output is 0. And at S2 I need to check for 2 cases, that is 1 and 0 and 1, okay. 0 and 1. So if it is like so I am checking. So here 1 0 0 I need to check, 1 0 1 I need to check, okay. So 1 0 0, so 1 0 0 means what? It will go to the initial state. So where it will be initial state? So that means 1 0 0, so 0, so where it is matching means it will go to S0, initial state, okay. So this is what? This is 0. I didn't got the sequence. I got 1 0 0, okay. So output is 0 only, okay. And this is non-overlapping, okay. This is nothing but non-overlapping. So 1 0 1 I got the sequence. Whatever the sequence I am searching, that I got the sequence. So when I get the sequence, it will start from the initial state, no? We already seen in the random sequence. That means in non-overlapping, when you get the sequence, here you got the sequence, it will start from the initial state. It will start from the initial state. That means it will start from 101 I got. Here it will start from 0. 101 I got. It will start from next 1, like that, okay. So that means in this non-overlapping, so it will start from the initial state. So that means here when you get 101 sequence, what happens? It will go to the initial state. It will go to the initial state. What is the input? Input is 1. I got the sequence, so that means output becomes 1. Output becomes 1, okay. So this is 101 sequence, okay. 101 sequence, okay. Is it fine? Do you understood? the state diagram? Any doubts? Waiting for your response. Hello.
No, sir, no doubts.
Okay.
No, sir, I don't have any doubts.
Yeah. Next you see. So this is nothing but what Mealy non-overlapping. Okay, Mealy non-overlapping case. Okay. So like this is one problem I told. So like this you can check for, suppose 2 bits are there. So 2 bits means 0 0 0 1 1 0 1 1 you can check. Okay, for 2 bits. Okay, 2 bits. For 3 bits, how many bits you can check? 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 I told. Okay, 1 1 0 and 1 1 1. Okay, so these many. So 4 cases you can check. Okay, you can do so that you will get an idea how this sequence is happening. Here you can check for 7 possible combination. Okay, so draw for Mealy non-overlapping for these 4 cases. Okay, and parallelly take this 101 as reference, and this 7 cases. 7 cases you draw. Okay, so I'm expecting in the next class you can show these diagrams. Okay, so take this as task. Okay, take this as task. Okay, you can show on Monday also. Okay, so this is about this 101 sequence. Okay, and next Mealy overlapping. Mealy 101 sequence FSM Mealy overlapping. So what is overlapping sequence? The output of what so we already seen in the Mealy machine. The final bit of the sequence can be the first bit of next sequence. Okay, so it can overlap. Okay, so final bit of the sequence can be the first bit of next sequence. Okay, so we'll just draw, and we will observe what is the difference between this Mealy overlapping and non-overlapping. Okay, so I'm drawing for same thing, that is 101 sequence. Okay, so 101 sequence only. So 101 sequence. Okay, so if it is a Mealy overlapping, what I will get? So here I am drawing for this one. This is what S0. Okay, S0. For each and every case you need to check for 0 and 1. Okay, so this is the reset state. Okay, reset state, it will start from here, and if it is 0, okay, if it is 0, where it will go? So normally you are checking for what? 1, but you got 0, it will be in the same state only. Okay, 0 and output is 0, it didn't got the sequence. Okay, and next if it is 1, so you got one sequence. So one sequence from whatever the sequence you are checking, it will go to the next sequence. This is S1. Okay, and this is 1. You didn't got the whole sequence, the output is 0 only. Okay, so that means input by output. Okay, see here state is there, state, and this is input by output. Okay, and next here which sequence you got? One sequence you got. Okay, one sequence you got. So in this I can check for what? 1 0 or 1 1. I can check for 1 0 or 1 1. Okay, if it is 1 0, where it will go? If it is 1 1, where it will go? So if it is 1 0, I got this one. So 1 0, I got the 2 bits from the sequence. So if you get the sequence, simply it will go to the next. So this is what S2. Okay, so this is what 0, and I didn't got the sequence. So here I got the sequence 1 0 only. He got the sequence 1 0 only. Okay, so the output is what? 0. Okay, output is 0. If it is 1 1, okay, I am checking for at S1. Okay, if it is 1 1, so basically suppose if I see here this input is 0 only. Okay, so 1 1 means what? It will be in the same state only. Okay, so 1, I didn't got the sequence, the output is 0. Okay, output is 0. Okay, and next I need to check for where here 1 0 I got at S2. I can check 1 0 0 1 0 1. Okay, 1 0 0 1 0 1. Okay, so this is overlapping, no? So this is overlapping means if it is 100, so 100 means where it will go. So here I need to check for 3 bits. 3 bits not possible. 2 bits also, if you see 2 bits anywhere, is it matching? Not matching. Okay, 0 means it is matching with the previous state. So that means if it is 0, it will go to S naught. 0, it didn't got the sequence. Actually I'm checking for what 100, but I got 101 and I got 100. So that means output it didn't got, the output becomes 0. Okay, so if it is 101, okay, 101, I need to see for 3 bits, 3 bits not matching, 2 bits 0 1 anywhere matching, not matching. 1, I need to see this 1. Okay, 1, you see 1 is matching. Where it is matching? At S1 it is matching. So that means where it will go? It will go from S2 to S1. Okay, so 1, the last bit becomes the first bit. So that means 1, output is 1. Okay, so this is overlapping sequence. So what is the difference between overlapping and non-overlapping? See here. So overlapping and non-overlapping means in so all the cases same only, but when you get the sequence in non-overlapping, it will go into which state? S0. It will go into S0. So here when you are getting the sequence, the last bit becomes the first bit. So that means it will go to, where it will go? It will go to S1. So you need to match the last 2 bits, last 3 bits, wherever last 1 bit, wherever it is matching, it will go to this state. Okay, so last bit is matching to the S1, so that's why it will go to S1. So you got the sequence, whatever the sequence you are checking, so you got this 101. Okay, so like this I can do. Okay, is it fine? 101 sequence, overlapping and non-overlapping. Any doubt in this? Waiting for your response. Hello.
No, sir.
No doubt, sir.
Similarly,
Understood.
you can check for 0 0 0 1 1 0 1 1. Okay, this is 4 cases, and same thing 0 0 0 to 1 1 1, except 101 I told you. This is 7 cases. Okay, so 4 bits means what? 1 0 0 1 to 1 1 1 1. Okay, so 6 cases you can check. Okay, 9 and this 10 to 15 is how much? 5. So like this you can check. Any sequence shall I do? Tell me.
Sir, can you do 1111?
111 you are asking, huh?
No, no.
4 ones,
Oh,
huh?
15. No, no, sir.
Huh?
4 ones, 4 ones.
4 ones, huh?
Double,
Okay,
double
okay,
one.
okay. 4 ones I will do. Okay, 4 ones I will do. Okay. So first 4 ones I will do first non-overlapping 1 1 1 1 Mealy non-overlapping I will do. Okay, after that we'll see overlapping. Okay, so that means in Mealy, how many number of bits are there? That many number of states you have. How many states total? 4 states you have. Okay, so that means states are S0, S1, S2 and S3. These are the states. Okay, so S0. Okay, S0, this is S0. I am checking for what? For each and every state I need to check for 0 and 1. Okay, what are the possible combination? If it is 0, it will be in the same state only. Okay, so 0, I didn't got the sequence, output is 0. Okay, if it is 1, I got one sequence from this, whatever the sequence I am checking, simply it will go to the next state. Okay, simply it will go to the next state. 1 second, please wait. Yeah, simply it will go to the next state. Okay, so next think I'm audible. Okay, 1 second. Yes. Okay, yes. So next this is nothing but 1 and output is 0. Okay, so here I got the sequence 1. Okay, here I need to write. Okay, and next at S1 I can check for what at S1 the possible cases are what 1 0 and 1 1. Okay, if it is 1 0, where it will go, and if it is 1 1, where it will go. Okay, so if it is 1 0, okay, so 1 0 means it will go to the initial state. Okay, 1 0, so 1 0 means where it is this 0 is there, so that means it will go to S 0. It will go to S 0. So this is 0 and output is 0. I didn't got the sequence. Okay, if it is 1 1, I got the sequence. Now it will go to the next state. It will go to the next state. Okay, this is S2 and I didn't got the sequence. Okay, so input is 1 and output is 0. So here I got the sequence what 1 1. Okay, so at S1 I checked 2 cases, that is 0 and 1. Okay, and next next at S2 two possible combinations are there, 1 0 0 1 0 sorry, one second, in this 1 1 0 and next 1 1 1. Okay, 1 1 0 and 1 1 1. Okay, if it is 1 1 0, so where it will go, it will go to this initial state. Okay, where is initial state? S 0. Okay, S 0. Okay, so that means this is 0, I didn't got the sequence, output is 0. Okay, and next if it is 1 1 1, simply it will go to the, so I got the sequence, no, so I got the sequence, so this sequence and this sequence I got. Okay, so 1 and I didn't got the whole sequence, the output is 0 only. Okay, and so this is what S3. S2 is over. Okay, so till S3 I got the sequence what 1 1 1. Okay, 1 1 1 I can get 0 or 1 1 1 I can get 1. Okay, I can get 1. Okay, so here if it is 0, okay, if it is 0, where it will go, so if it is 0, where it will go, it will go to this state. Okay, 0, so where it is matching 0, so that means it will go to this S 0. Okay, S 0. Okay, so if it is 0, it will go to S 0. Okay, 0, I didn't got the sequence, I got the sequence this one, 0 by 0. Okay, and here if it is 1 1 1, here I will get what 1 1 1, so freshly it will start, it will, so that last bit cannot be the first bit. Okay, so freshly it will start. So for this also, what is the sequence, that is 1, I didn't got, I got the sequence, the output becomes 1, output becomes 1. So this is the state diagram for 4 ones. Is it fine?
Sir, last state, can we go? We need to go to S1 or S2 after getting 3 ones.
It will start from the reset state, initial state.
Okay.
Reset state. It will start from the, so that means in the sequence I already told, no. So that means if sequence is detected, so it will start from freshly, it will start. So that means in this take some random sequence and you can check. Okay, so non overlapping means what, 101 if I get means it will start from the freshly, it will start, so that's why it is going into the initial state. That is the only difference we will get in the overlapping and non overlapping. Is it fine?
Yes, sir, understood.
Okay, next 1 1 1 we'll see. Okay, 1 1 1 overlapping we'll see. Okay, 1 1 1 overlapping. So yeah, 1 1 1 Mealy overlapping sequence. Okay, so how many states? 4 states, S0, S1, S2 and S3. Okay, so so I'm drawing S0. Okay, so So I need to check for two cases, 0 and 1. Okay, so if it is 0, what will happen? If it is 1, what will happen? Okay, if it is 0, it will be in the same state only, and I didn't got the sequence, output is 0 only. If it is 1, it will go to the next state. Simply it will go to the next state. Okay, so S1, the output is the input is 1, and I didn't got the sequence, output is 0 only. Okay, so here I got the sequence, one sequence I got at S1. Okay, and at next so at S1 I need to check for what? I need to check for two cases. What is that? 1 0 and 1 1. Okay, 1 0 and 1 1. So 1 0 and 1 1 means what? Two bits I need to check whether matching, not matching, and 0 means what? It is matching, so that means it will go to this state. Okay, 0 and output is 0. If it is 1 0, it will go to S 0, and if it is 1 1, if it is 1 1, it will go to the next state. I got the two sequences. Okay, so I got, it will go to which state? S2, and here input is 1 and output is 0. So here I got the sequence what? 1 1. I got the sequence 1 1. Okay, and at S2 I need to check for what? 1 1 0 and 1 1 1. Okay, I need to check for two cases. Okay, if it is like okay, if it is 1 0, okay, I need to check for 3 bits, 2 bits, like that. 1 0 wherever, anywhere matching in this. 1 0 not matching, and 0 0 where it is matching? 0 means here it is matching, so 1 1 0 means here it will go to S 0. Okay, this is input is 0 and output is 0. I didn't got the sequence. Okay, if it is 1 1 1, it will go to where? It will go to S3. It will go to S3. Okay, so here I got the sequence 1 1 1. At S3 I got three sequences. If the sequence is there, means it will simply, it will go to the next state. Okay, so next here I need to check for what? 1 1 1 0 and 1 1 1 1. Okay, so here I am checking, if it is 0, I am checking 3 bits, anywhere matching, not matching. I am checking 2 bits, anywhere matching, 1 0. 1 0 is also not matching. 0 is matching. So 0 is matching means if it is 0, it will go to S 0. It will go to S 0. Okay, so this is 0. I didn't got the sequence, output is 0. Okay, and if it is 1 1 1 1, okay, so I need to see 3 bits, 3 bits, not 3 bits, 2 bits you see. So 2 bits you see. So 2 bits where it is matching? 1 1, here it is matching, so that means it will go to S2. So 2 bits are matching, so that means 1. Okay, the output is 1. Output is 1. Okay, so this is the Mealy overlapping sequence. The only difference you got here is at the last state, when you get the sequence, it will go to the initial state. But here if you get the sequence, you need to see for matching cases, that is overlapping. Okay, so overlapping you need to check, and so where it will go, like that you need to see. Is it fine?
Yes, sir. Yes, sir.
Understood. So like this, try with this today task I told you, no. So today you need to try for this. So today task, Mealy non-overlapping and overlapping for 2 bit. Okay, 2 bit means for 4 cases, 0 0 0 1 1 0 1 1. Okay, 3 bit like 0 0 0 to 1 1 1, excluding 1 0 1. 1 0 1 I told. Okay, 4 bit also you try for 1 0 0 8 also there, 4 bit 1 0 0 to 1 1 1 0. Okay, so this one you try to draw this state diagrams for Mealy Mealy overlapping and non-overlapping, and show me any doubts or any queries you will get. Just ask me, I will tell you. Okay.